Now we are discussing the training set, development set, and test sets. What are these training sets and development sets and test sets? If we have 100 training samples, and for all these training samples, we know what is input X and what is output Y. We are giving these training samples to train our computer or to train our learning algorithm or to train our deep neural network. Now, in the traditional way, in the old times, and already we discussed even in the machine learning also, out of these 100 training samples, we should keep 70 training samples for the training. We will give the training to the learning algorithm. Based on that, we will get a perfect model. After that, we used 30% for the testing to check whether the model is correct or not, whether it is giving proper results or not. But later we discussed it is not the right approach. So we changed, instead of 70 and 30, we changed 60% and 20% and 20%. What is this 60 and 20? Now we are saying take the 60 training samples to design the model and take the 20 training samples to cross validate the model, to check the model whether there are any errors. If there are any errors, how can you change, whether you want to add the regularization term, what will be the best model, or you can check in this deep neural network. If I use the tan-h function, tan-h function, or tan-h activation function, or ReLU, rectified linear unit activation function, how the error is going to change. We are crash checking. That's why we are calling this as a crash validation set. But now we are calling this crash validation set only development set, because even though we designed our model by using 60%, we are checking, we are developing the model by using 20%. We have training samples. And after the model is ready, now we are testing our model by using remaining 20% training samples, whether it is correctly predicting the values or not. But today, but today even we do not want to do it also, the 60, 20, 20, 70, 30. Why? Because we are getting a very big amount of data, like 10 lakhs training samples or maybe 1 crore training samples. In these 1 crore training samples, if you are keeping 20, means in 1 crore 20 lakhs training samples for the crash validation is not a very good option, and 20 lakhs for testing is not very good option, because our original data may last, or we may not get that much of familiarity to design our model, because we are leaving 20 lakhs training samples. Now we are saying, when we are having the data like 10 lakhs training samples, take only 10,000 training samples for the crash validation or for the development. Take only 10,000 training samples for the testing. It is fine. If we have 1,000 training samples, then that ratio is fine. That ratio 60, 20, 20, that ratio is fine. If we have 10,000 training samples, then 60, 20, 20 ratio is fine. But in nowadays, the data is in the training samples, the input data is incrementing very drastically. We cannot expect even the data in 10,000s anymore. Now the data is in the 1 lakh, 10 lakhs, or 1 crore training samples we are getting. So when we are getting this much huge amount of data, it is not the right option to use in that huge amount of data 20% for crash validation. Instead of that, we are fixing, take 10,000 for the crash validation or development set, take 10,000 for the testing. Now in this 10 lakhs, this 10,000 is like 1% and 1%. Now 98% training samples we are using only for the training, and 1% we are using only for the crash validation, and 1% for the testing. You may also use 99.5% for the training, 99.5% training sample, 99.5% data samples for training, and 0.4% data samples for crash validation are developing, and 0.1% for the testing purpose. Because in the cross validation set, what we are actually doing, we are checking whether when we are applying these data samples, when we are giving these samples, whether the error is less or not. If the error is less, then there is no need to worry. If the error is more, then we are checking where the problem is coming. So really, our system design is properly being checked at the development stage only, or by using the development set or crash validation set only. Once we have fixed all the parameters, then in the testing stage, actually we are not doing anything in the testing stage. We are only checking whether we are getting proper results or not. If we are getting the proper, if we are not getting proper results even after the testing stage, then we have to go to the original training samples, and we have to go to the original model. Then we have to do some changes. But the problem in modern days is, you can get the data. Example, we are taking the pictures data as input. The cat, we want to recognize whether the given image is cat or not. So training set, we may take from the web pages, different web pages, the cat pictures. Some users may upload the pictures, very low resolution pictures, which they are taking by using the cell camera, mobile camera, that too when the light was not proper, and the resolution is very small. So these two pictures are different. One we are getting from the web pages, which are very high resolution pictures, and the second picture sometimes the user may upload from the mobile in the not proper light environment. So now in the development or test stages, if you assume some pictures are from training set, some pictures are from a very high resolutional pictures, and some pictures are very low resolutional pictures, then if you use one kind of pictures at the testing time, and if you are using one kind of pictures at the development time, then the problem arises. So we are giving advice, make sure that we should use same kind of distribution of the samples, or same kind of distribution of training samples at the development and test time. Means if we are using very high resolutional pictures at the development time, you use the same high resolutional pictures at test time also. If you are using very low resolutional pictures at the development time, you can use the same low resolutional pictures at the test time. But there is no restriction to the training set, because the training set is a huge data set. We cannot separate which pictures are low resolutional, which pictures are high resolutional, because we want to train our model with any kind of picture. Only we are taking care about the development and test set. Whatever the pictures or whatever the input we are giving, there should not be any mismatch in the development and test set. In the development and test set should contain same distribution of the data. Sometimes you may hear the word that we are not using any test set. Right, that is fine. If we can use only development set, because really in the test set we are not performing any operation, only we are checking. If we are very much confident enough that after the development set our learning algorithm is performing quite excellent manner, it is performing really nice, then there is no need to go for the test set. But it is advisable, if you go through this process, like first training the model, and after the model is ready, we are checking whether there are any loopholes, whether there are any the parameters to be changed by using the crash validation or development set, and then giving to the testing is the very good option always.